Bismillahirrahmanirrahim. This video is on the request of a student, and the request is to use matrix method to solve this practice problem. So this circuit, we have to find I naught. This is I naught. So let's first of all redraw the circuit with the currents, the loop currents or the mesh currents. This is I1, this is I2. This I'm not naming as I3 because this current 10 ampere is the current through this mesh. And now keeping in view the currents, I have marked the polarities. You know, wherever the current touches first, that is the positive terminal. So positive here, positive here, positive here for this mesh. And similarly for this one, positive here, positive here. And for this current, this is positive. So keeping in view now the marked voltage polarities, we are ready to write the mesh equation. So for mesh 1, we'll start from this point and go like this. So by KVL, this is 8 into I1 plus minus J2 into I1 plus, now you can see here there are two currents, J4 into I1. We are in mesh 1, therefore we'll write I1 first and then I2. So J4 I1 minus I2. So this is the first equation. We'll now simplify, collect the like terms with this is the I1 terms and I2 terms, and we are calling this as equation number 1. Now in the mesh 2, we'll go from here, plus J4. Now we are in mesh 2, therefore we'll write I2 minus I1. So I2 minus I1. Then here also there are two currents, I2, 6 into I2 minus this 10 ampere. So 6 into I2, minus, but plus, because they both have the same direction. This is also making it plus and this is also making it plus, and therefore we'll add. So I2 plus 10 ampere, and then this 50 angle 30. Simplifying this, we get the second equation. And now we can solve this with the help of a matrix. These were the two equations that we had. We can write them in the matrix form. And now let's recall the question. Question saying we have to find I naught. This is I naught. Now I naught is opposite of I1. You can see the direction, and therefore we'll write it that I naught is equal to minus I1. So the only thing we have to do from this is just to find I1, not I2. And the formula for I1, you know, is delta 1 divided by delta. And I hope you also recall what is delta. The determinant, this one, is delta. And we cross multiply. So this minus this. Now we have to be careful. I made a mistake here. First of all, minus sign. So there should be minus here. But this minus multiplied by this will make it plus. J multiplied by J square is minus 1, and the minus that should have been here, that makes it plus. And 4 into 4, 16. So it is plus 16. And for delta 1, we just replace the first column with the output. So replacing this with the output, and again cross multiplying. So the first term will be 0, and the second term will be minus, and again multiplying this. So it is minus multiplication of this, and these two minuses will make it plus. So this will be the delta 1. Okay, so we had delta and delta 1. I1 will be delta 1 over delta. Writing these two values and solving using the calculator, we should be getting this term. Now let's see if we can get the calculator. Okay, so we have the calculator now, and we'll input the values by having the calculator in complex mode. And I hope you know already. If you don't get complex here, then you press mode 2 for complex. So 2. So we are in complex mode. Now this is numerator divided by denominator. Therefore, we'll pick this one here. And now we'll write the top. So minus bracket sign 103.3 plus J25, that is 25, and I. This is I. So 25I, bracket close, then bracket J4. So bracket 4I. For J we write I. Okay, so the numerator part is complete. Now we move to the denominator. From here, press down. Okay, so we are in the denominator. Bracket 8 plus 2j or 2i, bracket close, bracket j plus 64j plus 4i, bracket close, plus 16 plus 16. So we have done the entry. Let's move ahead. Equal sign. Now this is in rectangular form. To go into the polar, we'll use this complex function. So shift complex. R theta we want. So 3 equal sign. So 5.968, 5.968, and angle minus 114.49 or 52. So this is how you can calculate using your calculator in complex mode. I hope you have been able to follow this. Thank you.